Great. Okay, I'm turning recording on. I think Daniel said he's going to be a bit late. I don't know about anybody else. John said he was in a meeting just now. So I think we should get started and see who jumps in. If you guys are good at that.
Yep. Yeah, sounds good to me.
Right. So sorry, Kristen, keep going. So you use Carbon in what you do?
Yes. Yeah. Yep. And then at a later date, I can give you a tour of the cloud platform where you can sign up for it and explore around yourselves. But yeah, I've been doing that for almost 2 years now. And the piece that I work on is billing. So like we create all of the UI, and outside of the UI too, all of the interactions around how people pay for cloud and they understand their usage on cloud, understand their spending. Like we've designed everything from physical invoices to like a usage dashboard and different things. So it sounds like y'all have a dashboard going on. Like backing up to a bit, I'd love to just like hear who each of you are and like how you've been involved in the project, and also where the project's at.
Okay, I'm going to start. So I'm the founder of Grillo, and Grillo is the startup that started to some extent OpenEEW. We're one of the founding members, and we sort of created a network in Mexico, and we did some in Chile and some other places, but it was really Mexico's been the focus, and we started that in 2015 with help from USAID and some other people, and then at some stage we realized, I think it was about last year, we sort of made a decision that, this is really hard work for one company to do. I think partly because it's not the most sustainable business, sending alerts. Like there are facets to it which we're more involved with now in terms of insurance companies and other types of clients. But providing life-saving alerts, which is, to be honest, the reason we do this, it's the reason we started this. Providing life-saving alerts, it's a hard one, and so we just figured that if it was an open source community, we're going to have much more impact, and we're going to be able to really reach many more people and do many more things. And so we had this horrific moment where we had to sort of decouple ourselves from the project, and we sort of realized that, if it was going to be Grillo on its own, it wasn't ever going to go anywhere. And then, it was IBM came in through their code and response, now Call for Code, the names have sort of come together, and supported the project, and then helped us with the Linux Foundation. And so now, we're very happy that it's now a sort of like broad effort, by ourselves, by IBM, the Linux Foundation. Today, we just had a call with our technical steering committee, and there's a new member from Facebook who's joining us. So we're sort of trying to create a team around it. Do you guys want to say anything else, Vaclav, Ryan?
You want to go, Ryan, or shall I?
No, I was just going to say, my name's Brian Kelly. I'm a web developer and software engineer, and I teach web development at the coding boot camp at UC Riverside here in California. And when this project was announced as part of the Call for Code with IBM, I got a notification on it and started contacted Andy. And since then, I've just been working on the web dashboard side of things, and I just love working on this project. I think it's just such a cool idea, and has such a great application, in the world. And like most of my day-to-day is working on web development projects that usually are static websites or somebody trying to sell some product or whatnot. Not to disparage the day-to-day work of a web developer, but this gives me the opportunity to work on something that's just a really awesome project, and I think it's just got a great community. But beyond that, I work on the web dashboard, which we're building now, which is hopefully going to be, when it's finished, kind of an entry point to the application to be able to, or to the network to be able to visualize visualize the devices across the network, and also the accelerations that come in from each individual device.
Yeah. So and I'm Václav, and I just finished my PhD in seismology at Oregon State University about half a year ago, and I was always kind of thinking about EEWs because I really like this application of seismology, and I really liked OpenEEW that was emerging right at that moment when I finished, because it was using, well, it is using these cheap sensors that have the potential to...
We say low cost, not cheap.
Okay, yeah. Yeah, I was actually... People say that to me, yeah. So, yeah, these pretty awesome sensors, actually, that are maybe not high precision enough for seismology, but for EEWs, they are just perfect. So, yeah, I was looking at it and I was thinking that I could join in and help from the point of my expertise from seismology. So, yeah, I spent last couple of months thinking about this and contributing a little bit.
And also talk about your Nepal project.
Yeah, that's another thing. I wanted to test the OpenEEW network and system in Nepal, where we have some experience because we worked in there after the 2015 earthquake, the almost magnitude 8 earthquake that was in there. And so we have connections with seismologists and geologists in there, and we kind of want to test out the system in there, whether it can work. So I'm still in the process of finding most of the finances for this, although we found some already. So it's still up in the air whether it's gonna go and when it's gonna go with the coronavirus and everything. It's complicated, but hopefully next spring we could go out there and deploy some instruments and actually start working on that.
That's amazing. And help me understand real quick too. Who is using the dashboard? Are they governments? How does this compare with what exists right now? You said it's not exactly as precise as what seismologists might use.
Oh, you mean the OpenEEW dashboard, or? Well, the thing is that in seismology you are trying to capture very small earthquakes, about magnitude 1 or 2. So those are like very, very small earthquakes, and you are not really interested in those small earthquakes in earthquake early warning systems, because those earthquakes usually don't cause any damage. For damage to be caused, you need you have to have about magnitude 4 or 5 or something like that. That is quite shallow. So for seismology, those earthquakes are very important, because based on the distribution in time and space, you kind of need to infer on some things, on geology and physics of earthquakes and stuff like that. But for earthquake early warnings, you are mostly interested in those strong earthquakes. So when seismologists build earthquake early warnings, they use these very high precision sensors, but those are very expensive. Of course, it would be great to have a very dense network of many instruments that will be high quality, but it's not very sustainable, and it's definitely not sustainable for countries like Nepal, because that would be millions or tens of millions of dollars that would have to be sunk into the system. But for the task that we are doing for recognition of quite strong earthquakes, what is enough is actually sacrificing some precision of the sensors, but actually gaining, first, like, you are making it much cheaper, and second, you are able to deploy many more instruments in the area, which is actually more important for us than having fewer instruments with better quality of the data.
That makes sense.
I don't know if that was what you were asking about. Maybe I was, yeah, okay.
Yeah, that absolutely makes sense.
I believe, Kristen, you're also asking about who uses this.
Correct.
And I think that the short answer to that is nobody at the moment. Like, so just to make this a separation between what Grillo has done and then what OpenEEW. So like Grillo has got a network in Mexico, and we have many hundreds of users, but thousands of users. But we are, but that's different because we have to manage a whole infrastructure here in the cloud, and there's all sorts of risks involved of getting things wrong. You know, so this is not an experiment. We've been doing this for a few years, but because it's been working so well, we then sort of distilled the core parts of that, and thanks to the team here, are packaging it up so that anyone can deploy it as easily as possible. And I think that's been our work, is to take all these little bespoke services that we created in Amazon Web Services and just sort of bring them into a way that anyone can use on any platform. And so we haven't really created a deployment yet, but the idea is that anybody could. So like, in Nepal, for example, that cloud could easily create a deployment which could then benefit everyone in Nepal. It does need some management because it can't be completely decentralized. You do need someone to make sure the sensors are working and etc. But the technology is now within reach of anybody, and there's no loss in quality. Just because the sensors are lower cost doesn't mean that they're worse, because if anything, you can have more of them, and density is better than quality to some extent in EEW.
Okay, that makes sense. So what I'm understanding is it's technology that Grio has that has been kind of like extrapolated, and y'all are opening it up so that it's more accessible, and it's
exactly
it's a separate entity from Grio. Okay.
Yeah. For example, the work Ryan's been doing, which would be wonderful if you could have some input there into the way people would use and experience this. That work, the way we've done it, I'm talking about the dashboard. The way we've done it is we've used sort of Grafana and some open source tools, but it's really been cobbled together, and it was good enough for our internal team, but it's not something that we think is fit for purpose. Like, it's not something that anybody anywhere could just pick up and do, and it's very specific to the way we created our databases, etc. So really what we're trying to do here is just package everything up in a way that's easy to deploy.
That makes sense. Yeah, I'd be curious, guys. Also, I have not done my homework. I need to go back in the GitHub and read documentation. But I'm curious. It sounds like there are different pieces. Like, there's the sensors. I can't list them all, and part of it is the interface. I'm wondering too, like right now with the way that it functions for Grio, who the different people are that interact with it. It seems like there's the person who goes out and sets up the sensors. And then are they governments, or are they?
Okay, so you're asking all the right questions. We haven't had somebody from your side of asking these questions. And they're really important because it's so easy to think of this as a technology problem, and it really is so much more than a technology problem. There's a whole social aspect, and people who've created EEWs in the past have got this wrong. You could argue that the whole West Coast shake alert system, which is currently in production, has been built, tens of millions of dollars from Congress every year. You could argue that was given to a bunch of scientists, and they didn't give enough attention to the social science aspects of what they were doing early on, and they're having to sort of backtrack a little bit, because you should start from the users. And I think people often just think, oh, sensors, cloud, alert, and they don't necessarily think about how or why. And there's also an education piece that people seem to forget about as well. What do people do with these alerts, and what are the causes of and effects if you get things wrong? So to answer your question as best as possible, there are the people that install the sensors. And we ideally, going forward, we probably want to make life easier for them, because in our experience, it's horrible installing sensors. It's horrible. You go to this remote place, you engage people, they don't really know why they're going to help you. And then once they do help you, you then have to sort of install this device in the thing. And then you need to provision the device so that it connects to the cloud. Ideally, you do that through an app. We don't have that at the moment. We sort of just tell them how to. It's a horrible process, but yeah, ideally it would be easy for people to provision a sensor, and then there's somebody on the team who has to manage the network of sensors. Are they all working? Are they not working? They have to check the dashboard that we're making to see the status, or maybe they get alerts or whatever it is. Then there are the people who receive the alert. How do they receive the alert? Do they get it through a mobile app? Do they get it through some other system? Like behind me, if I unblur my background here, for example, these things behind me are 4G speakers that we install in schools. So they have a little 4G mode. So what do people do when they hear that the siren or etc.? So there's all sorts of ways people can receive the alerts. So I would say there's a broad thing. And then there are people who need to buy in. So you mentioned the government. There needs to be some buy-in from authorities, because, you can't do this independently of the local authorities. How do they monitor the system as well? Do they have access to the dashboard? What can they do when they're in there? That's the first thing that comes to my mind.
Yeah, and I would, some of the stuff that we've talked about with the web-based dashboard is trying to facilitate some of those trying to make things a little bit easier for people to set things up and visualize how the network is working, and possibly even last time I think we talked about maybe possibly areas to expand it where you could have some sort of guidance on where to put the sensors, or if the sensors are set up correctly, and whether or not the how the network is operating. So some of the stuff that I think we've been talking about with the web dashboard is trying to just make it as accessible and as easy to obtain and set up. Part of the issue with that, what I personally keep going back and forth with in my mind is how to connect it to kind of the other components, because there is a technical issue with balancing the ease of use and the accessibility with the technical qualifications for having to connect with all these different sort of containers and whatnot in databases. But that's, the dashboard is in such a beginning stage. I mean, I've actually I can share my screen if you want, if you want to see kind of the where it is right now. I've added the chart to it.
Do y'all have anywhere written out, you may have all of this and I just haven't seen it yet, written out like that sequence of events, of steps that have to happen in order for this to get set up and work accurately? You were kind of describing, at first I was imagining the people who were setting up the sensors, trying to connect, but then I was thinking of how much of that is also done through the dashboard, and just like that sequence of
yeah. So the let me go to up here, and we have for the dashboard, at least we have a bit of a roadmap that describes how we're going to get to version 1, but I've already thought of some stuff to add to it. It's a little bit general right now, but it's in, right now the stuff that we're talking about with the dashboard at least is really just some basic functionality of it, right? It has this accelerations chart, which needs to be better. It has sort of a listing of network devices that right now this is just the UI of it. This isn't actually live. It's not connected to any database right now. And then
that wasn't there before, the network devices. That's nice.
Oh yeah, so this is off of. I added that table to start sort of expanding the UI out. But this is on my own. I'll do more for this, and after it gets a little bit more fleshed out. But it there's a lot. This is the kind of just the basic elements that we've discussed so far. There's a lot of stuff that we've talked about that's not in the roadmap right now, where we could take the dashboard to try and make it more accessible and be more of a hub for whoever's managing these networks.
Yeah, I would say Ryan, and this is where Kristen's expertise would be really, really wonderful. Is I almost imagine how there'd be different sort of going in the future. There might be different views or dashboards, tabs, depending on what the user might be. I mean, I can imagine that this set of information is very relevant for someone who's looking at the devices and seeing how they are, but there might be another one with a map on it, which might be good for the overall manager, and there might be another one for, I don't know, there might be different views, I imagine. However.
Oh yeah, definitely. This menu over on the side here, which just has settings that doesn't go anywhere. I definitely would see that filling up with all sorts of things like network maps, accelerations page, maybe some sort of like guide, like wizard to set up devices or something like that. I mean, there's a lot of places, all these different sort of views can kind of pertain to all the different, functionality involved in setting up a network or managing a network.
But
yeah,
sorry.
No,
but none of it is probably for the end user, right? Like the end user is actually just interested in that receiving the warning, but this is more for the technical side of it. And yeah, just summing up, I don't think that this would be really used by the end users, right? The dashboards. It's more for people who are setting up the networks and doing the more technical.
Yeah, I would think, unless Andy, you can think of an application for the end user. But yeah, definitely this would be like the hub for like the network management and whatnot.
I completely agree with that. If I think about, say, for example, the Mexican seismic system or the Japanese system, I think there might be, some way for the public to be interested in looking at, they might be curious about the system, and it might give it some validation if they might be a web page where they could occasionally see the status of the system. But it's really less important. Yeah, I mean, this is an internal tool for the people who are managing the network.
Yeah, one of the ways that, at least in our projects on my team, that we make sure that we're solving for each of these things is we'll define, and maybe I'll have this already, each of the different personas that we're designing for. And then for each of them, writing out use cases, like person X can do this, like can achieve this task or complete this job, and listing all of those out. And often we'll list those out, and then there are things that get scoped out of different releases, but at least having that clarity helps us like align around what we're trying to solve. So that's like one thing I'd be curious with y'all, and to find like at another time to sit down and just kind of pick your brains and understand like who are each of those different personas for this, and starting to.
We totally haven't done that, and that would be really valuable. We just jumped straight in and made all these assumptions, which are very likely to be just that. So it would be great to do that exercise.
Well, and I also bring zero or like very, very little seismic related knowledge.
No, but as Andy was saying, I think maybe we are really approaching this from, the technical side and from the seismological side, but we are not. Maybe we should really think a little bit, or try to think the other way around, at least a little bit. How are we going to use that product, either us as technicians or seismologists or the end users? And maybe we should really try to reverse our logic in a way and try to approach the problem from the user side rather than from what we can do. If
you work backwards from the alert, so think about being the person who gets the alert. This is the most important user, you would suggest. The person who gets the alert really wants the smallest amount of information as quickly as possible. They just need to know something's about to happen. Now you can go further and you can tell them more, about that event, how strong the shaking will be, how many seconds until all of that can happen. But effectively, what they really care about is almost a sort of a siren. And if you work backwards from that, it's, how can we deliver that alert as quickly and efficiently as possible? And how can we make sure that we don't get that alert wrong, in terms of, a false alarm or something like that? That for me that's always driven us at Grillo, is to make sure that the person who gets, because if you get it wrong, and we've got it wrong before, everyone gets it wrong, even the US government and the Mexican government and the Japanese government. When you get it wrong, people lose faith in what you're doing. And it doesn't take much for that to happen. A couple of false alerts, and people don't trust the system. And when that happens, you've got a real uphill struggle to get the trust back again. Because what you've done, if you've ever experienced these, and I have them frequently, I'm here in Mexico, when an alarm happens, you grab your family and your heart races. Like every other night, it happens. And me and my family get out of bed. We have this pump of adrenaline that goes through our body. We grab our two little kids. We run downstairs into the street in our pajamas and our underwear with all our neighbors. And we're outside of there, and we're fearful, and often it's freezing or raining outside, and there we are in our underwear with our little children, and we're fearful. And so people will only put up with that so many times if there's no shaking. After that, they'll be like, I'm just going to stay in bed. So you have to get it right as much as possible. And another aspect is you have to be transparent. So in the information, you have to explain. We will get it wrong sometimes, and this is how our system works, and this is why sometimes it doesn't work. And I think that there's a sort of responsibility around that as well.
I'm curious, Andres, so you've got the speakers that you point, or the alarms that you pointed to that are behind you. Yeah. I guess it surprised me a little that y'all were that far into each of the steps that I was kind of alluding to in the journey, that y'all are even engaged in the actual alarm system.
Oh yeah, I know. That's just one of the ways we do it. So I mean, we have, where's my thing? Well, so somewhere here I have, we sell these things on Amazon. So on Amazon we sell these, which are little alarm devices. and we tell people how the shaking will feel in their location. We deduct what energy will be lost before it gets to them, and every person will receive, strong shaking, weak shaking, depending on where they are. And this gives you, like, in Mexico, a minute or even minute and a half before the shaking. That's not true everywhere, just in Mexico. And then we also have an app that people use, and then those are for schools in remote locations. But that's, all of that technology, actually, we're going to be sharing as much as possible. In fact, I gave some of these to our team members to work on, because we can open source this as well. It's basically the same technology as the sensor. And the app, I put it on the website, but that needs a bit of work on GitHub. That needs a bit of work.
I guess one of the reasons why I was asking about that was I was wondering, okay, if you're and maybe I'm too hung up on the government component of this, but I can imagine like rogue systems like this coming up, and then like alarms going off that are not, I don't know if regulated, but like the consensus that this is the official announcement. And I wondered, what's your interactions been like?
So we had an interview with the Wall Street Journal, which I can find and share, where they asked that question: how can private companies do the work that you would assume a government to do? I think the first thing is, well, sometimes there is no government that does it, like in Nepal. There's only a handful of these things in the world, so sometimes there is no government that does it. You can get around these. You can get around any liabilities by being very clear what it is that you do and what you don't do. And you can say, this is information. You can use it how you want. We're just giving you information, and that usually gets you out of trouble. But in the case of Mexico, we have had issues with the law here, and we've proven that our system here in Mexico, which cost us, a couple of $100,000, was far better than the Mexican national system that took 3 decades to build and cost hundreds of millions of dollars. So you can just explain things to people.
Yeah.
But you have to be careful, because people do take these alerts very seriously, and you can get into trouble if you do it wrong.
Of course.
Yeah. Well, I'm sorry, go ahead.
You're good. I was just going to say, I appreciate all of the background on this project. It's really cool, honestly. So I'm excited to be involved. I've got like 10% of my work time that I can dedicate towards other projects. And so I think that's what I can give to this. And like, as for next steps and stuff too, I'd love to just start somewhere in our documentation, I don't know, like listing out who are the different personas, and to the extent that y'all can fill in like what you think each of the use cases is for each one of those, and I can set up a structure for it, and we can have conversation around it. But that might be a starting point.
That's awesome. Yeah, in Slack we can have calls anytime. I suspect the dashboard will be one of the use cases, because some people won't be using the dashboard, like we've said. So yeah.
I think eventually we should also probably define where, or maybe you have it defined for GRIO or even EEW or OpenEEW, but what the end product is supposed to be, whether we want to go all the way from recording ground motion through processing data and then alerting everybody, the end users, or as you were saying before, just providing information, some kind of API or something to people who then can take the information and then use it somehow in an app or something. Because I think there's a lot of that social component, and we are probably all more on the technical side, and I think that there's a lot to be done on that. Or correct me if I'm wrong, I don't have any experience with the actual application of the warning feature, but I think that there's a lot to be done. And for example, in Nepal, I'm kind of hoping that this system shows up to be feasible, that some either governmental or non-governmental organization that is already doing some kind of seismic risk mitigation in there, that they're going to take it and use it somehow, the information, and maybe develop more the social side of the things, and educate the public to how to use actually those that information when an alert happens, because it's a lot of work to educate the public to a point when your phone starts ringing and an earthquake alert is delivered, for you to know what you are supposed to do when you have 10 seconds to react to it. And yeah, and I think that we should probably also define what the end product of the OpenEEW is supposed to be, whether we really want to go all the way to the alert and to educating the public, or whether we want to stop somewhere along this way and actually leave some work for somebody else who may be more into that side.
So I think this is great. I think we've never fully answered this, and I think we will always talk about this, and we may never quite get there. But you're right, and I think the hard part has always been the infrastructure. So creating infrastructure is in my opinion probably one of the greatest innovations. That we can create sensors, create firmware, create a dashboard, create alerts. Getting to the point before it gets to the public is always the hard part. And if you think about the way other places have done it, like the Shake Alert or other places, they do everything up to the end, up to the client experience. So what they do is they have the APIs. I know because we're actually a partner of Shake Alert, and we've been authorized to provide alerts along with other partners. So I think it makes sense that you would go up to the point of the alert, and then you would engage other people to do it. And you need to, because some people need it from radio, some people television, some people SMS. You can't prescribe the channels that people will use to receive the alerts because you want everyone to get it, and you need redundant systems to get everybody. Overlaps. So yeah, I think we can keep having this discussion, but my sense is that the client device, we should be slightly agnostic as to what it is. So like when we created the first repos for this project, we put an example of the mobile app, and we're going to put an example of one of these alarm devices. But I feel that like you said, that should be up to that can be open to anybody, in my opinion. That seems to be the best way to do it. But I'm open to anything. I appreciate that's a tough discussion to have, because some people might want to do everything, and good luck to them. So I've just been aware that Gareth's here. Hi, Gareth.
Hey, I'm in my car, so can you hear me okay?
Yeah, loud and clear. Loud and clear.
Oh, great.
Did you want to contribute anything? I know you've reviewed the sensors this week. Did you have anything you wanted to say?
Well, I made a few comments on the layout for you to have a look at, but it's basically a very good layout. So we must be close to being able to do the second version.
Great. Yeah. Yeah, I think we are. So based on your comments, I sort of feel comfortable as well. I haven't heard from Raphael in a couple of days, and I'm hoping that Raphael can help us do the final routing. But if we get the routing done, I think we should be good to go. From our side, we've actually gone ahead and ordered a whole lot of components, specifically the accelerometers, just to have everything ready. We're going to do them in Mexico. The idea for Kristen's benefit here is that we realize not everybody can make sensors themselves, and actually it wouldn't be economical to make just a handful, because you have it's cheaper to buy in bulk when you do these things. So we're going to manufacture sensors and really not make any money doing it, but at least pass on the savings of doing it in bulk. And we have some partnerships that will help us bring the prices even further down. So right now, Gareth has helped more or less approve the sensor design. So I think we should be quite close.
So when do you think that the second batch is coming up? I'm sorry, Gareth.
I was just going to say, what was the reason not to put the GPS actually on board?
Yeah, I don't think there was any great reason. I think we would just let's make the sort of the minimum viable product, and then we can add things later, because the GPS helps us with really, really precise timing, but you can get away with not having that and just using internet time. I think that was our hypothesis.
Okay.
I know that
because those GPS modules.
Yeah.
I was just going to say those GPS modules seem to be very cheap. How much does the cost of the GPS compare to the other components on the board?
Oh, hang on, Gareth. So I'm gonna contradict myself. We actually created a header to plug in those GPS modules. So we have so what we created on the sensors, we have a couple of headers, and one
I missed a bit of that question.
I'm sorry.
Yeah, sorry, I missed your question if there was one.
Yeah, no.
Black spot.
I was just answering that we do have a header to plug in a GPS module. We expose some pins. So actually anyone can buy one of those from AliExpress for $6, and they will then have sub-millisecond time accuracy. So we did include it. I forgot. We just didn't integrate it into the board. I remember I once created a board with GPS, and it was a real pain in terms of the radio system. I think he's in a tunnel. So, Vaclav, were you going to say something?
Yeah, I missed part of your question. I didn't realize.
No, there was no question.
No,
Sorry.
There's no question. Okay.
Just that we do have GPS. We do have it as an option.
Sure. I was just wondering why you didn't have it on board rather than as a pluggable option.
I think just to get the board done as quickly as possible, because I thought it might add some complications. Maybe we were wrong.
Yeah, but like you say, it's no big deal because you can use internet time, which is good enough.
Yeah. Yeah. So anyway, so I'm excited. We have quite a big waiting list of people because I think the majority of people who are part of our community, maybe not actively contributing, but at least interested, have expressed an interest in the sensors because they probably do not want to have to worry about manufacturing them. So I feel that the moment we can deliver these sensors, we have a huge waiting list of people who want them right now. The moment we can deliver them, I think OpenEEW will benefit greatly from it. I think a lot of people will then be able to start playing with this in a way that maybe they can't at the moment. So I'm hopeful this will accelerate things for the community.
I got a couple of questions about the sensors. First, I know that you were opening a debate about how if you are not going to use a cheaper or more low-cost microcontroller, whether it would be better for if we don't run any complicated detection algorithm on the sensor itself. So it may first decrease the price and also decrease the power to the sensor. But we need to probably, in that case, we would have to think about what we want to do on the edge, and what kind of processing we want to run on the edge device. But if you are using the ESP32 still, I think that maybe I misunderstood that question in Slack somewhere.
So I think we're too far down the road to change at the moment from the ESP32, but for the next version we probably will. But I feel like that's still 6 months away, given all the work that has to be done. But for this version, the ESP32, I think for the next version, we still have the opportunity to be more selective about the microcontroller. So I think what we really would benefit from, maybe you can help with this, is just at a very high level, what might we want to do on that processor? What logic might we be running there? Because if we could define that, then we could work out more or less how much memory it should have, how good a processor it needs to be, and then we can define it.
Yeah, that should not be too much down the road from my side, because I'm now working on the detector, and detection and some kind of basic station magnitude computation is going to be probably the only thing that we can dedicate to the edge, because from the logic of the thing, we can't do much more. So we should be able to say how much, like, first what the detector we're going to use, whether it's going to be some machine learning, like neural network, or whether it's going to be something simpler like STL-LTA that is going to provide the same detection standards.
But
So
there
we should not be too far from it.
But there is a third option, which used to be an issue for me when we tried it here, which I think we might be able to do, which is that we don't do any. This will be a sort of in between option, and I'm curious to hear your thoughts. Is that we don't do any detection again? We just wait for a threshold. So, like, is the acceleration above x? And if it is, then we send everything. And we keep that threshold very low, so we really do get anything at all. So, we'll be triggering on false positives, but at the least in the cloud, we're only going to be getting packets of 2 minutes of data every now and again, not constantly. And so we still need to do detection, but we can do it in the cloud. And because we're only sending packets every time we have a certain threshold, which could be a human movement or something else, but at least then we reduce the telemetry down to the point where we can use cellular or something else.
Yeah, I think it's a good idea. The only problem I can see with this, or a possible complication, it's true that we can run the same detector on the cloud, which is not a problem. The only thing is that we would have to set up the threshold somehow reasonably high, so we are not getting constant triggers from noise, but also reasonably low, so we are getting earthquakes that we might not be issuing warnings for, but still strong enough earthquakes like magnitude 4s, because we still want those earthquakes for evaluation of the system. We still want to record them, calculate the magnitude location, and have some kind of metrics on how the system performs, because otherwise then we would be, I'm a little bit worried that then we would be getting just quite strong earthquakes that are much fewer of them than...
Yeah, you raise an interesting point, because we've installed sensors in locations that are noisy, and they require different thresholds to other sensors.
Yeah,
I always thought you could automate this. You could have a sort of background algorithm that's sort of like working out what the average noise and peaks are, and then calibrate automatically. But then
it's like STLTA probably.
Yeah.
No. But I know what you mean. Yeah. So we can think about that.
Let's have a discussion offline, I think, but we definitely need to define what we want the sensor to do in the future. For now, we're stuck with the ESP32, which is quite powerful, but we do need to define this.
Yep. And also, my second question was, how far down the road do you think that the second batch of the first generation sensors is? Like, when do you think that it's going to get manufactured? Because as I said before, I got some money from the Institute for buying some of them. And
so whereas previously we used to send everything to China, I've actually got a partnership with a local assembly shop. They have the machine which creates the printed circuit boards. It's called a pick and place. You have a tray full of components, and a robot sort of puts them on and puts it into an oven. And so they're going to help us make them. And the benefit to having it really close to us is that if the components don't change, it means that we can iterate much faster. So all we have to do, if we just have to reroute things on the circuit board, we can make those and get them shipped over here in a couple of a week or 2 weeks. What takes time is if you do assembly internationally, because then there's a whole they have to ramp up to create the assembly and program their machines. So to give you an answer, I would think that once the design is ready, Raphael suggested that we could be done very soon. Then, I've already got some components being shipped at the moment to Mexico. So I would have thought, 3 weeks or so will be
that's great.
The first few. And if those have problems, then we'll have to look at them again. But once it's working, we can really get them out. I think a month to be safe. A month, given the work we still need to do, a month to be safe.
Yeah, that sounds great, though. Thanks.
Sorry, Ryan, you were about to say something.
I was just going to ask a question about the engineering of the sensors. And is there a so you were talking about the difference between doing the detection calculation on the sensor versus in the cloud? Is that and so what would be the advantage of doing it on the sensor? Is it a speed question of how fast you can get basically the detection algorithm to run and send out a signal versus doing it, for example, in the cloud? Is that what drives that decision?
Yeah, well, it's a whole topic in the world of IoT, which they call edge computing, and I think, and it's actually an old topic, which was distributed computing. And the idea is, if you have processors that are capable of doing bits of the work, you should really be using them rather than having a big, powerful, monolithic server somewhere that does it all. I think the benefit is there's a couple of benefits. The main benefit is that if you can do some of the processing on the devices, then you're not going to be sending huge amounts of raw data every second forevermore. You know, we have enormous amounts of telemetry all the time being sent to the cloud from every sensor, whereas, you know, 0.01% of it is relevant to earthquakes. So by doing some processing, you're only going to send information when there's an earthquake. And it would just make the system much more efficient. It would also mean that what's happening in the cloud has to ingest far less data. So you could have it on a much lighter weight system. You know, you could potentially run all of this on a Raspberry Pi if we get it right, in my opinion, who knows? But, you know, if all you're doing is receiving a couple of packets of data every time there's an earthquake, this is really, really low, you know, low computing requirements. Right now we have, you know, monster virtual machines in AWS and all of the other services. So, you know, and having telemetry reduced means you can have different options, not just Wi-Fi and Ethernet. You can have cellular, LoRaWAN, other options, and then you can start to be creative as to where you install these sensors.
Yeah, that's interesting. It's almost it's a little bit, I guess, different than thinking about it in terms of web development, because oftentimes in web stuff you're trying to have most of the calculations that happen be in server side. You want AWS or some sort of cloud system to handle it, because you don't know you don't know how fast people's computers are or how much a browser can compute. Whereas in IoT, it's almost switched, because you do know all that information, right? You're the one designing that, so you have that capability.
Yeah. So yeah, I think we started off by not doing it. So like the current firmware and the current sensors don't do computing on the device, and we did that actually very deliberately because we wanted all the data in the cloud initially. I think we've benefited from that, but because now we can test algorithms and look at it. But I think now that we're trying to create a sort of efficient system and we have the data in the cloud, it no longer makes sense to do it the old way.
I think it's really great that the Mexican network has this, that is sending all the data in, because yeah, now we can test out algorithms and do all this stuff. And when possible, this may also be good in the future if we can get somehow at least the earthquake data in. As you are saying, maybe sending chunks of the data that are going to be, you know, after some basic detection or threshold or something, so we can do the algorithm testing and stuff. But also it would be nice to have something very, very lightweight for situations like Nepal, where we have only cellular, at many places we have only cellular connection. So doing the edge processing will really allow us, or would really allow us, just to send a few bits of information that will be, yeah, like amplitude and detection time and stuff like that.
Yeah. So Ryan, you were showing us your dashboard before. Was there anything else you wanted to say about your dashboard? Or is there anything? You know, someone who's been absent is Agivio. I'm going to see if I can engage him again, because he was working with you before on this.
So yeah, what I decided after I had a little bit of technical issues connecting it with the detection Docker, and I started trying to mess around a little bit with the detection Docker to maybe send signals to the dashboard backend. And then I thought that, well, I'm altering the detection Docker in ways that I don't really want to, because I kind of want to keep that pure. So at a certain point, I just decided to create just a multi-container Docker that has timescale DB running as a service inside of it, and then the API and the client is running two other services. So I changed our layout for that just a little bit. So right now, with what I'm working on in development, it's not super important, because it's just kind of the back end technical aspects of it. But right now, there is a timescale DB as a separate service for the dashboard that is now separate from the detection Docker. And I think I'm going to need either his help or somebody's help with trying to connect those two, because it's there's a technical issue, but then there's also the question, like we've talked about before, of do we want to have the entire database in the detection Docker? Do we want some sort of alternative, external database or external service that basically connects everything, the users for the dashboard, the raw accelerations, the detected earthquakes, that could just run as kind of its own separate service somewhere, and all these different aspects of the each container can kind of connect to that wherever that is, whether it's a container or if it's just a standalone database on IBM Cloud.
I know that Daniel and John are looking at this right now. So I know they're looking at this because we've been talking. I've got some news actually I was going to share with you guys, but because we're looking at a Caribbean project, which is going to be a big OpenEEW project, and also recently the World Bank has shown interest in OpenEEW for a project in India. So in these cases, the idea would be that we simplify everything. We simplify. We define the architecture in a way that makes it easy to deploy, because we haven't done that. You're completely right, Ryan. So John and Daniel are going to propose something, and then I think you can comment and everyone can comment on it.
Yeah, and that sounds good. I mean, when I'm working on this, my thought is, and this goes back to what we were talking about with Kristen before. It's the easiest way to set up this database would be my recommendation for it, even if this means possibly turning this into not necessarily a web app, but like a desktop app through Electron or something like that. I mean, React basically can become any of those other things fairly easily. But however, when I was trying to connect the detection Docker before, it was a lot of sort of moving files around and put this Docker compose file into here. And my thought immediately is just, I don't want that part of the documentation. Like setting up this web application should not include all this sort of file manipulation and running all these sort of build processes. It should be just a fairly simple, like, install this or just upload it here and have an audience that's not necessarily technical, or even a technical audience that doesn't know web development all that much, be able to really get a hold of this fairly quickly. And if that could, with the sensors, if that could somehow, connect to the sensor really easily. I remember when I was in college, I had this program running SETI at home on my computer, which was everybody loved SETI at home. But I would imagine, and obviously there's other qualifications involved in this, right? But I would imagine that there would be a lot of users that might want to set up a sensor themselves that don't have a lot of technical knowledge from computing or seismology or any of that stuff, who just kind of want to be a part of this system and help out in that way. And they're, right now, I think with the way that we've set up, for example, the web application, I think it would just be a little too intimidating to start running all these Docker containers and whatnot.
I think you're right. And I think, and so Kristen, that's a really good point here for thinking about users, because I can imagine exactly that sort of user, the citizen scientist who wants to just help or contribute. And if you're that guy or girl, you're going to want to see the data. I think you're going to be curious. You're going to be, okay, well, I'm contributing, but to the extent the dashboard that you've already created, Ryan, I think would be the sort of thing I would want as a citizen scientist. I want to see that stream data. I want to know that my sensor is doing something, and I want to see it, alive to some extent.
Yeah, perhaps there could be different. You could have different access roles to the dashboard, or there could be different views of it depending on what's most relevant to you.
Yeah, I still got some confusion, because I think every case might be different, but imagine that you're setting up a network in Nepal, for example, or in New Zealand. Are you going to let citizen scientists host your sensors, or you're going to be the one who selects the citizen scientists? There are some unanswered questions here, and I think that will determine who has access or doesn't have access. and I wonder whether those things might change in every network.
I could see it. I mean, that sounds similar to like the little bit that I've learned about blockchain, the idea of having like private networks or ones where you can control access and open some of it up.
Yeah.
Is there a minimum number of sensors that you need in a network to get good, calculations? Essentially, is it more about like where they're placed over quantity, or is it more sort of quantity is always better?
I think it's both. Quantity and also distribution matters. Yeah, and it's hard to say the limit for the quantity. You can do something with 10 sensors. Of course, 100 is better, and 1,000 is even better. So yeah. I think eventually, we should be probably with decreasing price of the sensor and stuff. We should be shooting for closer to the 1,000 or thousands, maybe, if possible. And if this turns out to be manageable in terms of keeping all these sensors alive, and I think that's what we should shoot for. On the other hand, I think several tens of sensors do quite a good job too, as you can see in Mexico.
I would say in Mexico that the first phase of our sensors, we went and put 10 sensors down, and we were generating alerts every other day. It was really seismic at the time. So you can really have very few, and it's better than none. And the important thing is to put them in the most active places. And then you will have blind spots when you have few. Eventually, you try and cover those blind spots. But
Not to interrupt, I've got to go host a meeting right now, so I got to drop.
I think we're going to say goodbye. I think, unless anyone, yeah. Okay, great to have you guys here.
Likewise.
Yeah, good to see you too.
Absolutely.
Thank you.
Okay.
Yep.
Bye.
Have a good day, guys. Have love. Kristen, Andy.
Take care, everybody. I'll see you on the next one.
Yep.